Alright, let's talk about complex numbers. Alright, complex numbers are actually a mix of two numbers in a sense. Complex numbers. Sorry, let's spell it all out. It's when you have a real number, right here, plus a imaginary number. Or, that's a complex number. Or a complex number is a real number plus a real number times I. That's basically it. Sounds complicated, right? No, it's not very complicated actually. But if you didn't get any of that, well, guess what? You're not supposed to, because we're gonna get into counting. All right, let's start with counting. And yeah, we're really going back to square one. Why do we call it complex numbers, and why do I not want to study it whatsoever? Well, there's reasons. But let's go into the evolution of the number. So counting, let's talk about that. So let's put some time periods. Well, let's have something to count in the first place. Let's draw some sheep. I can draw some sheep. Pretty good sheep right there, right? Ooh, look at those sheep. Perfect sheep. People know me for my sheep skills. Alright, look. Yeah. So there's things to count. So let's talk about certain time periods. And by the way, some of these methods still exist today. It's just, I was about to do that backwards. So about 10,000 to 4,000 BCE. This is how we did stuff. Oh, here, let's list off the time periods so I can be ready for them. Then 4,000 to, let's say, 1,000. I'm not really making these up on the fly, but I kind of am. You know. Also have a habit of writing a smaller one first, even though technically this is earlier, this is closer to today. Then we also have, let's give it, let's say about 1,000 to maybe 0 BCE. Yep, that's good. And then let's end with much closer to the modern era. 0 to, how about 1,500? Common era. Alright, that's before common era, common era. Alright, whatever. We're done with those little boxes. So let's talk about what happened during these eras. So during these years from 4,000 to 10,000 BCE, what we did is we actually did no counting whatsoever. We did this thing called mapping. Alright? And if you're thinking, oh, so they would draw a map of the land and then they just point at where the sheep are on the land. No, you're completely wrong. That is not what mapping is. Mapping is not some kind of, let's roll, yeah, fun. Anyway, no, that's not what it is at all. Mapping is actually a ton more simpler than you might think. So let's take our hand. All right, I would almost draw it out, but I don't want to cover the whole thing. Let's draw. There's our hand, all right? So here's what we do. We'd see each sheep, and each one, let's start with the index finger. So index finger would be this one. This one, so like we'd pass by a sheep and we'd use a different finger. So this one would be index finger, middle finger, ring finger, and pinky. And so then we passed by all our sheep, and so we would say up to our pinky in sheep. That's how many sheep are there. Now, of course, this would be in their native tongue. This would be how they counted, not how, they measured basically amounts. And so they wouldn't really count. They just know that, okay, so if I pass by sheep and I end up with this many, I'm missing a sheep because this is not the normal amount of sheep I have. Or if I gain one, somehow I got an extra sheep. Awesome. Or I don't know how the extra sheep came in there. But pretty straightforward method. So each finger will represent a different sheep. And honestly, some people took it as far as they'd use their whole body, every body part basically, for a counting method. There's some people in Indonesia who had, I believe, 42 different digits. Well, let's call it body parts. And they'd use every body part to count. And so they would have, basically, if you care about a base 42 system, you're probably used to a base 10 system. I've been using base 10 system in all my videos, but a base 42 system would have 42 different numbers, except for, here's the thing, they didn't really have numbers. What they had was body parts. And so they might say they have up to their nose, which might be our equivalent of maybe like 12. So up to their nose in I don't know, grains or something like that. And even cooler, if you had a second person, which they usually did. I mean, if you're a civilization, you're probably not just one person. Well, if you took a second person, you could say up to your nose here, that would be 12 on the first guy, and then maybe up to your nose again. So maybe that'd be 12 on the second guy. Except for that wouldn't represent 12 plus 12. No. What that would represent is you went through 12 times in order to get to that number. So actually you would have 144 if you said up to your nose and up to your nose. That sounds weird to say, but whatever. The idea is you're counting up to your nose. So you'd use every body part until you got to your nose, which would be, technically I'm still counting, you just can't see it. Well, not counting, mapping. That's the right word. Either way, you get the idea. After you go through 12 one time, you then move on to another finger, 12 another time, then 12 another time, then 12 another time. And so you'd get really big numbers really fast. And so these methods were actually not primitive, don't feel primitive at all, and they shouldn't. In fact, I believe people in Indonesia still use them today. But honestly, and then you introduce a third person and you get 12 times 12 times 12, which I don't even want to figure out because that's a pretty big number. Alright, you get the idea. So mapping, it's you see something that you understand and you bring it to something you see. So maybe that's one of these, one of these, one of these, one of these. And that's called, by the way, one-to-one mapping. Technically, you already understand mapping in mathematics. Mathematical mapping, which is you see a number, let's say 2, and you have 4. So you could map 2 to 4. You could bring these to each other via a variety of methods. Maybe one would be plus 2. Another one might be times 2. Another one might be squaring the number. I just usually put a box there, put a square there. So all of these methods would get you 4, and so each of these methods is a way to map 2 to 4. It's a way to basically change a number to another number. Now, in the real world, mapping is pretty much just seeing something and you're like, okay, that's my first finger, that's my second finger, third finger, and fourth finger. Except for you'd have a name for every different finger. You get the idea. Let's move on a little further in the future. 4000 to 1000 before Common Era. So this is when we started moving past mapping. Mapping is good, but it's relying on fingers, and sometimes we'd have like tally sticks, but you have to make another tally stick every time you want to count something different, or you'd have to have complicated methods of relying on these sticks that you'd use to measure numbers, well, amounts, not really numbers. So we developed, not numbers necessarily, but counting. Or at least I would call this counting. And guess what it was? It's about when we started writing on stuff. And so what we'd do is we'd see all these sheep and say, okay, that's our first sheep, second sheep, third sheep, fourth sheep. Now we might not have those numbers as words yet, but that would be how we'd write it. Or maybe 4 slashes. Or maybe 4 slashes this way. Or maybe a mix of the two. All of these would represent the same amount. And this was counting in its best. In its purest, I mean. And so that's what we did. And there's like 2 Babylonian times. And now this is when we start to get to Greek times. That's when we actually assigned numbers to things. know what a number is? A number is a symbol to represent a quantity. That's a really vague way to say it, but it's good enough. So you might write 4 in Roman numerals like this. I know I'm using Roman numerals when I just reference the Greeks. The Greeks would have something really much like this, or they'd have like their own letters for different amounts, and they'd keep using those. And so this was a pure idea of the number. And Greeks love things that are whole, and things that you could evenly split apart. So maybe this might be 4 pieces, or it might be 8 halves, or it might be maybe you don't count this piece and so you have 7 halves. They accepted all of that. They wouldn't accept something like this. It'd be about this much. This would be about square root of 2 halves. No, they would not like that at all. Well, actually, square root of 2 halves would be something like that. So this would be square root of 2 pieces, actually. Either way, it can get more complicated than that, but the idea here is that they liked whole numbers, but still, they had this idea of the number and splitting it apart. And that brings us to the most recent, 0 to 1500. This is basically the era when we basically ended our crazy systems of counting. I mean, we still edited our units, but basically our common number system today all came from this era. And by the way, this is all over the world. This is actually more of the Eastern world, being India and Saudi Arabia, those regions, Persia. So let's talk about what happened during this era. Well, what we had was basically better numbers. There's not really another way to put it. So this is how we would count. We would just have a different symbol for every amount. Maybe we might have this for 1, and then maybe something, I believe it was actually a lot like that for 2, and then for 3 I think it was something like that. I don't know. I'm totally guessing. I don't exactly remember when I was reading up on it. But I know that 4 was basically a cursive Y. And these somehow transform themselves into these crappy numbers I write today, that no one from their time would realize that what these symbols even were. But these transformed all because of this era, and this is the common number. This is called Arabic numbers, or technically they're Indian numbers. Arabic numbers. And I'll put that in parentheses. Quotations. Yeah, it's Indian. Quick little side thing. They're called Arabic numbers because people in the West got these numbers from the Arabic world, which in turn got it from the Indian world of this time period. And it's a huge time period. Lots of other things happened that adapted how we multiply and count. Multiply and basically operations on numbers. So this is basically the timeline of counting, I would say. Evolution of the number. And so by this era, we actually had numbers, and we were slowly finding out ways that we could change these numbers and invent newer ones like negative numbers. And yeah, it gets more complicated, but I think you get the idea. I'll move this another video. There's going to be a bit of a series on complex numbers. So let's talk in the next video on timelines of not counting anymore, but messing with numbers. How do you edit? How do you alter numbers? Calculation. That's what I mean.